Now we're going to be looking at complementary results. Now complementary results is results that are opposite of each other. For example here, complementary of probability of A will be 1 minus the probability of A, because 1 is the total probability. 1 is the entire probability, so if I subtract probability of A from 1, the remaining is what I'll get. So say for example, if P is the probability of surviving, okay, of living, then 1 minus P will be the probability of dying. So see how dying and surviving are complementary events because they're opposite of each other? So to get one or the other, we subtract 1 from that particular probability. So do you get the idea? That's what we're going to be using for the next few questions. So let's try the questions. Starting from 24. Each question in a multiple choice test has 4 listed answers, of which only 1 is correct. A student guesses at random the answers to the 3 questions. In part A, he wants to find the probability that none of them is correct. 1 out of 4 is the probability that he'll get it correct. So the remaining probability, which is 1 minus 1 over 4, which is 3 out of 4, is the probability that he will not get it correct. It's wrong. So if he wants all 3 to be wrong, it's going to be 3 out of 4 times 3 out of 4 times 3 out of 4, which is simply 27 over 64. Now B, find the probability that at least 1 is correct. So we could have 1 correct, 2 correct, or 3 correct, but we can't have none correct. So we can't have them all being incorrect. Because it says at least, you must really identify what at least means. And we've actually found that probability here. We found that having none of them correct is 27 over 64. So having anything apart from that, it would be 1 minus that, because that is complementary of this. So we simply subtract that from the total probability, and that will give us the probability of having at least 1 correct. Because the only event that we won't include here is when it's all 3 are not correct. So I've just subtracted it from 1, and the remaining is the answer to this question. Question 25, the probability of a product is defective is 0.01. So it could be defective or it could not be defective. 2 of them has been selected. So part A, find the probability that both are defective. This is the probability of having one product to be defective. So if it's both defective, we simply multiply them together. And then B, find the probability that 1 is defective, which means we want 1 to be defective and the other to not be defective. Defective and not defective are complementary events. Having not defective would be 1 minus 0.01. This is the complementary of that one, isn't it? Having defective and normal, or normal and defective. Again, consider the 2 events. Make sure you consider both. And then it will be 0.01 times 1 minus 0.01, which is 0.99. This is 0.99. Or 0.99, then 0.01. And then you add them because it's or, so you should get something like that. Use your calculator if you need to. Now C, find the probability that at least 1 is not defective. Okay, again, we've got at least 1 is not defective. So like one of them could be not defective, both of them could be not defective, but I don't want both to be defective. And I found the probability of both being defective in part A. That's what we want, which is at least one of them is normal, which is 1 minus both defective. That's what I said, isn't it? So we found this in part A. So subtract it from 1, which is the total probability, and that's what you should have. Question 26. 3 people are shooting at a target. Their respective probabilities of hitting the target are 0.8, 0.7, and 0.4. So they have different probabilities of hitting the target. Find the probability that the target is hit. There's different probabilities for each of these people to hit the target. It means at least one of them is hit. So even if one of them don't hit, as long as one of the other 2 hits, then we still treat it as the target being hit. It means that 1 person hits the target, 2 people hit the target, 3 people hit the target, but we don't want none of them to not hit the target. We should subtract 1 from all of them failing to hit the target. So that makes it equal to at least one of them hitting the target. All we need to do is find the probability that all of them fails, which means 1 times 1 minus 0.8 times 1 minus 0.7 times 1 minus 0.4, because those are the complementary events of hitting the target. So multiply them all, subtract it from 1, and that's what you should get. 27. A box contains 4 times the number of 10 cents as 5-cent pieces. A coin is randomly withdrawn from the box and replaced. This is done 3 times. the 10-cent coins is 4 times the 5-cent coins. So the ratio would be 4 to 1. The probability of 10-cent coins would be 4 out of 5, and the 5-cent coins will be 1 out of 5 because the total parts is 5. So those are the probabilities of those individual events. Now A, find the probability of getting at least one 5-cent piece. So we want at least one 5-cent piece. It means I could have one 5-cent piece, two 5-cent pieces, or three 5-cent pieces, but I don't want no 5-cent pieces. It's going to be 1 minus the probability of having no 5-cent pieces, which means I'll have three 10-cent pieces, isn't it? So it'll be 1 minus the 10-cent pieces times 3 times. It's going to be multiplied because it's 10 cent, 10 cent, and 10 cent. It's and, so we multiply. And that's what you should get. So you subtract from 1 again because it says at least. Now B, find the probability of not getting 3 5-cent pieces, of not getting. So this is the opposite of getting 3 5-cent pieces, which means not getting 3 is the complementary of getting 3. I should subtract getting 3 5-cent pieces from 1. So it will be 1 minus the probability of 5 cent and 5 cent and 5 cent, which is 1 minus 1 over 5 times 1 over 5 times 1 over 5, 3 times. That would be this. Question 28. Kia has a bag containing 5 red and 3 blue apples. 2 apples are drawn in succession from the bag and eaten. So it's eaten, so it's gone now, it's no replacement. Find the probability that the apples consumed are at least 1 red. So how many are we picking? 2. There to be at least 1 red, which means I want it to be 1 red or 2 red, but no red. So I'll simply do that. At least 1 red means 1 minus the probability of getting both blue and blue. 3 out of 8 apples are blue. So we'll have 1 minus 3 out of 8 times 2 out of 7. This one here would be 3 out of 8 are blue, and then because we eat 1, there will only be 7 left to choose from, and there'll only be 2 blue apples left. And then if you calculate this, you should get 3 out of 28. So 1 minus 3 on 28 is 25 on 28, and that's the answer. 29. 2 cars are available for rent in a rent-a-car shop. The probability that any of them is available for renting is 0.85. So there's a probability that the car is available. Find the probability that no car is available. So the probability that's not available would be the complement, which is 1 minus 0.85. So if both of them are not available, it would be 0.15 times 0.15. So 0.15 times 0.15 is the probability that both are not available, and that should be how you simplify it. And B, find the probability that any car is available. This is the probability that it is available. Now that's the probability that none of them are available. 1 minus that, because if it's available, it's the opposite or the complementary of when it's not available. So we simply subtract that from 1 to get the remaining, which represents the probability that any car is available. Question 30. A and B are complementary events with this property. They say 2 times the probability of A is 3 times the probability of B. And it's asking us to find the probability of B. Because probability A is complementary of probability of B, I would say that probability of A is 1 minus the probability of B. So now subtract that into here. So this is 1 minus probability of B. Substitute it in, expand it and simplify it. And you can see that all I've done is expand and simplify here, guys. And then you divide both sides by -5, and you should see that negative cancels. 2 on 5 is the same as 0.4. I found PB. 31. There are 2 even prizes in a raffle which have total 200 tickets. There's 200 tickets in total. And Mike buys 15 out of that 200 tickets. So find the probability that he wins both prizes. So if he's really lucky, he can win the 2 prizes. What is that probability? Well, 15 out of 200 is the probability that he will win a prize. It will be 15 out of 200, and when 1 prize is gone, we'll have 1 less prize that we can have. If one of the 15 prize or win, then we'll only have 14 left that could be possible to be a prize. Because we've already picked one, there'll only be 199 left to choose from. So this one is no replacement, without replacement. So calculate that, that's your answer. Now B, Find the probability that he wins at least one prize. So he could win one prize, he could win two prizes. I don't want no prizes. So I want to win at least one prize. I don't want to go home with no prizes. That's what Mike wants. I can say it's 1 minus the probability of having two no prizes, having no prizes at all, which will mean that 200 minus 15 is 185. So 185 out of 200, which is the complementary of the winning the prize, that is the probability of not winning any prizes. For the next pick, if he doesn't want the prize again, it will be 1 less than that, which is 184, because we don't have any replacement here. So we subtract 1 from numerator and denominator. So if I subtract that from 1, that will be the answer to this question, which will simplify to that. So that was some complementary events.